Anything you want to ask?
No, teacher, can continue.
We are in electric current. And you are supposed to be asking question. If not, I'll be any question to ask. If not, I'm going to go to structure already.
I can go to 16.
What number?
16.
15.
16.
16. Okay, let's go to 16. Okay, 16.
Yeah.
When an electric field is applied to a metal conductor, the free electron drift with a velocity v. If the mean time between collision is t, the mass of electron is m, the charge of electron is e, and the electric field is the E, the correct expression for V. Okay, this is just memory work. Right? This one looks like this type of equation for conductivity. And go to your definition, conductivity equals to J over E. And J over E, instead of conductivity, you just place it there. Then J, place it with NEV here. And you can cancel out the one electron here and one electron here, electronic charge E. Cancel the E, the N also can cancel off. Okay, so you are left with V, and E can take across there. So it's E T over M. Okay.
Okay.
I think the easiest way is to consider, that's the alternative lah. Consider that it is initially at 0 velocity, and then it is accelerated to velocity V. Right? That's the other alternative. I just thought of it. Instead of doing so difficult, I think of it as
Actually, I think confirm I'm going to school in next month because they say phase 2 already today. You heard that?
Say again?
Today is phase 2. Teacher heard of it?
Yeah. So exam student, they will allow you to go back to sit for the exam, no?
Yeah.
Right? You can use this one if you want to. Your V equals to U plus AT. If you find this is easier, your U equals to 0. And that is equals to your you can use your A is F over M. F over M times your T. Right? F is your force. This one is simpler lah. That's all. Use your U equals to 0, your F equals to F, your A equals to F over M. And then instead of using F, since you are given your, don't know why I go and do so complicated. Just thought of a simpler way. Right? EE. Okay, this is simpler. Then that was the next question. No need to go to a complicated formula. Just treat it as a uniform acceleration. Start with zero velocity. Then use this formula. Replace your A with force over, that's what I'm doing. Force over mass. And then force on the charge is just, first on the electron is just E times E over M. Okay, next question. Yep, any more? Any more? Yep. Any more? If not, I'm going to go to do one or two more before we go to structure.
Oh, 21.
21. Two cylindrical resistors are made of copper and aluminum, respectively. The cross-sectional area and electrical conductivity of copper is 4 times the cross-sectional area and conductivity of aluminum. If the length of both resistors are the same, what are the ratio of the resistance of aluminum resistor to resistor of copper resistor? Okay, let the aluminum conductivity of aluminum be sigma. Let the cross-sectional area be A. Then remember that your conductivity is 1 over resistivity. And we can use this formula. That's your STPM formula. R is rho L over A. Put your conductivity inside there. That's all. Then play with the formula. Take all the constant to one side. They are told the same length. So rho and A take to the other side. Then your resistor is the same. Then this is for aluminum. This is for copper. Right? So you want a ratio of aluminum. So take copper to the other side. Go to the other side. Take these two down there. Now put in your value. Right? Copper is 4 times the area. And that is your aluminum. So rho cancel off, A cancel off, so it's 16. Donkey. Okay, next question. Yep. What is the next question?
We can go section B then.
So no more question to ask. Then let's go to section B. Okay, as I said, not a popular question. It doesn't come out every year. Okay. The current of 15 ampere flows through copper cube of size 10 cm. Assuming each copper atom contributes 1 free electron, density of copper is given, molar mass of copper is also given. Right? You can memorize the formula, if not derive it. Calculate the number of electron in copper cube. Okay. Mass there contains 6.02 times 10 to the power 3 atoms. Or just memorize this formula from your last semester's work. Number of mole equals to number of atoms divided by Avogadro's number, or mass of the atom, right? Mass of the substance divided by molar mass. And then just play with it. You got density. Density is mass over volume. Okay, so your mass from here, take your MR across there, right? MR across there. So replace this mass and here. So you got NA, and then the V is still there. Then we want N over V. N over V, as I said, memorize the formula easier rather than derive that formula. Then substitute your value, density, and then Avogadro's number. Yeah, your table of constant, and then there's your mass. Okay, can.
Okay.
The volume is change it to meter cubic. Okay, so number of electron, this is per unit volume times your volume, no? So that's why you get number of electron in the copper cube itself. Any comment? If not, let's carry on to part B. State the main factor that the drift velocity of the free electron. Right, go to the formula that we have derived just now a while ago. Right, factors are the electric field strength, greater electric field strength, greater drift velocity, and the time of collision. If greater time of collision, greater drift velocity. Right? This is the time between collision, remember. Determine the drift velocity of the free electron. Okay, use that formula, memorize it. I is NEAV. Put in your value for I given. N, we have calculated. E, charge of electron. A is your area, hospital area. Okay, anything that not clear? Yep. Okay, okay, let's go to question 2 then. Yeah, I didn't remove the sorry, it's hanging out on me. Yeah. How come I've done all this? Sorry, just give me a little while. You can see that most of your questions are calculation. So if you don't know how to calculate, you will be losing out. Okay, nearly done. Okay, let's go back to number 2. Okay, conducting wire with cross-sectional area A has a number of electrons per unit volume N. The electron have a tree velocity V and charge Q. Derive an expression for the current which flow through the wire in terms of A, N, V, and Q. Okay, let the length be L, length of wire be L. So the tree velocity is L divided by T. Then definition for current. Current Q is total number of charge. Total number of charge times your that is your volume. Is number per unit volume times your volume is your number. Number times charge is total number of charge. That's your Q. Then your T is just your length divided by time. We just take our T across there, that's all. Then VD down. And simplify. L and L will cancel off. VD will go to the top there. Okay, that's our answer. The copper wire has a diameter 4.25 millimeter, carries a constant current of 8.0 ampere. The number of electrons per unit volume is given. Determine the drift velocity. Right? So usually derive, then they use the equation. No? Right? This equation that you have derived. Right? VD. You know how to derive. Make sure you memorize the formula. Right? Your I there, your N, Q, A, take to the other side. Cross multiply, then put in your value. There's your current. There's your number of charge per unit volume. One. Q is the charge of the electron. Area is pi. And then this is diameter, I divide by 2. Change it to meter. Square that. Okay. Anything that's not clear?
Okay.
Determine the current density in copper wire. They're just trying to get you to calculate all the terms, that's all. J is NEV. Or you can put I, since you already calculate. If you calculate. Why did I go and do so? Current density. Current density, just divide by area, that's all. Why I go and calculate this one? Just use your current, easier, divide by cross-sectional area. Yeah, it's nothing wrong to use this equation. Right? Since you got I, you got A, use that faster. Yeah, doesn't matter. Either one also can. Copper wire. Okay. So the other alternative is J equals to I stroke A. Okay, that's the other alternative. Copper wire is stretched while the current is kept constant. What happens to the magnitude of the current density? This is just application, right? This formula that you use. The formula, current is constant. When you stretch, it becomes thinner. So cross-section area becomes smaller. Right? When wire is stretched, the cross-sectional area decreases becomes longer, it becomes coefficient A decreases, the current density increases. Okay with that? A decrease, your J will increase. Any comment? If not, let's go to the next one, number 3. Have you been doing your homework or not?
I was doing, teacher.
You don't do, you won't benefit. You're wasting your time here. It's me doing your homework for you only. You won't learn anything. Learning is yours, not me. A lightning discharge a current density. There's a current density 30,000 for duration. There's a time. The potential difference between the bottom edge of the cloud and the surface of the ground is that volt there. Calculate the number of electron flowing per unit area for each lightning Okay, how to calculate? What formula to use? Yeah, what formula to use? Yep. Didn't do your homework, that's why I say.
No, I did, teacher, I did.
Then what formula to use?
J equals to I over A.
Yeah, start from here. Current is related to electron. Right? J is I over A. Then your I is dq dt. Then Q is N times E. Right? Your T is your time. Then put in your value. You want the number of electron per unit volume. So you want N over E. Sorry, N over A. So you take your T across and your E down. That's what you get. And put in your value. Right? J is there. And that is your time. Change it to second. And then the charge on the electron. Air is an excellent insulator, but it becomes an electric conductor when the electric field strength exceeds 3 × 10⁻⁶ Newton per Coulomb. Determine the electrical conductivity of the air between the cloud and the surface of the ground during lightning. Okay, what formula to use? Yeah, how is J and E related to conductivity?
J equals to E pi.
Yeah?
Yeah.
Conductivity, J over E, definition. Put in your value of J. There's a value of J. And then there's a value of E. Sorry, here is the one. And calculate out. Okay. You can put Siemens if you want to, or for ohm. No? Determine the energy transfer per unit area for each lightning. How to calculate? What formula to use?
T equals to VI.
Say again.
T equals to VI.
Right? P equals to VI, okay. U is just your PT. Then replace your V, replace your P with PI, and your T. And put in your value. Right? The voltage you already calculated. And then your I. What am I doing? What am I doing? Current. Did we calculate current? Oh, this one is per meter. So that's why we use current density. This current density instead of current. Right? Because you want per unit area. And then your time is given. Okay. 10 milliseconds. Any comment? Anything not clear?
Clear.
Okay, let's go to question 4. Okay, Now we go to section B. Okay, not a popular question. Some years doesn't come out. Popular is this area, but sometimes it does come
So
out. I think no. Popular maybe this area, this one, drift velocity. Okay, define drift velocity. Yep. What is drift velocity? These are all scoring points. You should be able to memorize it by your fingertips. Yep. Be able to tell me, since you have just done your exam.
It is the average velocity of free electron in a conductor when an electric field is applied along the conductor.
It's the average velocity of free electron in conductor when the electric field is applied along the conductor. Okay, let me just remove this hiding the. Okay. Derive an expression for the relationship between current in the wire and drift velocity. Right? Just I is NEAVT. Right? Very popular question. Let the length conductor be L, N is number of charge carrier per unit volume. So your total number of charge is just your number times volume. Then you times your charge. This is the number times your charge is the total number of electron or charge. And definition of current, dq dt. That's your charge put inside there or differentiate it. Right? N is constant, A is constant, Q is constant, so it's dl dt. dl dt is your drift velocity. That's all. Okay. Okay, let's carry on.
Okay.
Is your part B. Okay, okay, let's go to the next question. Household wiring contains copper wire, which has a diameter, there's a diameter, and a maximum current, there's a maximum current. Calculate your density of free electron in copper if each copper atom contribute one free electron. So how am I going to start doing it? Density, basically want you to calculate your N. No? How to calculate that? Yep. Any idea?
E and A over M.
Say again.
E and A over M.
You can memorize the formula. That's what you want. Number per unit volume. Right? Memorize the formula. That's what it means. N over V. And put in your value. Since you are given your, right? It's hidden here. Density, Avogadro's number, and molar mass. Right? This one you have to convert it to kilogram. Okay. And after that, you are asked to calculate current density. You just want it to play with the formula. Current divided by area. Current is 20. This one divided by 2. Right? And convert it to meter. Square that. Okay. Any comment?
Not each.
Okay, sorry, it's all hidden up. Cannot see. Let me just remove it and just read the question. Calculate the drift velocity of the electron in the wire. explain the effect of increase in temperature on the drift velocity of the electron in the copper wire. Okay, just getting you to memorize the formula, that's all. Or we just derive it. Just use that to derive your J over NE, right? Or I over A. Okay, calculate that on. Yeah, anything not clear?
Clear, sir.
Okay, then how to explain the last part? Effect of temperature on drift velocity. Yeah.
As the temperature increases, the resistance of oil increases. That's all I know, sir.
Huh? That's all. You're supposed to
Mm.
explain microscopically, not as a not that is true, but yeah, supposed to try to understand what's happening. Basic idea is temperature increase, the ions of copper is going to vibrate faster, greater amplitude. Greater amplitude means collision is likely to occur more often compared to previous. So it's likely to have a shorter, right? Just using this formula. As temperature increase, amplitude of vibration of copper ions increases, more collision with electron, resistance to motion increases, distance between collision is shorter, so the drift velocity decreases. Okay? Can?
Can.
Basically, your drift velocity is just dependent on this formula. There is the formula that we have derived earlier. Okay, there's your drift velocity. There is the question. Where is the question? Where is the question? Where is the question? That was the wrong formula to use. But yeah, what's happening? Sorry about that. Just trying to relate for you. Where is the formula? Sorry, trying to trace a formula for you. What is happening? Okay. Okay, remember this formula? Right? And know how to derive the drift velocity. Right? That's what it means. Amplitude increases, more collision. More collision will mean that this time will be shorter. Right? It won't. This is the time between collision. So as it collide more often, then the time of collision becomes shorter. The drift velocity becomes smaller or decrease. Okay. Yeah, okay, let's go to the question 2. Copper wire has a length quite long, 9 meter. Potential difference of 115 volt is applied across the wire and current flows through the wire for 150 seconds. Determine the current in the copper wire. Okay, how am I going to do that? Remember what is given. Resistivity is given. Electron density is
R equals
given.
to EL over A.
Say again.
R equals to EL over A.
Okay, good. R equals to rho L over A. Put in your value for resistivity as your length, change it to meter. And then this one divided by 2, convert it to meter. Let's square that to calculate out. Right? I don't know why your answer gives this one. What do you get? What answer do you get?
My answer, Acha.
Huh? I didn't do.
No, I did.
What do you get?
Same as you, Acha.
Your book gave 6.86. I don't know what did he do wrongly. Then calculate the drift velocity. How to calculate?
Drift velocity I equals to V over R. No. V equals to I equals to NEAV.
Right? Calculate your current. Sorry, we haven't completed yet. Calculate the current V over R. Put in your value. Right? Your V is 115. Your R we have already calculated. Right? So you use this value, then you get this one. Okay.
Okay.
So drift velocity. Right? Just use your I equals to NEAV. V I over NEA. Put in your value for I.
Teacher, the meet is going to finish in less than 1 minute, sir.
Yeah, okay. We'll stop and start a new Zoom.
Okay, thank you, sir.
We'll stop here. Start a new Zoom.